Bismillahirrahmanirrahim. Assalamu alaikum. I'm your teacher with the 6th lecture of basic mathematics. The topic which we are going to discuss is sequences and series, in which first of all we will define the sequence. In our normal language or real life, we define a sequence is just a list of elements and usually written in a row form, like 1, 2, 3, 4, 5 with comma sign. 4, 8. The second example is 4, 8, 12, 16, 12. Just a list of elements usually written in a row form is called sequence. But the symbols, these dot dot, is called ellipses and reeds, and the so on forth. Now the formal definition which we are going to discuss of sequence is: a sequence is a function whose domain is a set of integer greater than or equal to a particular integer and not. Usually this set is a set of natural numbers or set of whole numbers and set of integers and other sets. And the notation of sequences is an, which denote the image of integer n and call it a term of sequences. Thus a1, a2, a3, a4 dot dot an represents the term of sequence defined on the set of natural number. A sequence is described by the listing the element of a sequence in order of increasing subscript, and finding the term of sequence given by the explicit formula, the form which is if we have a sequence a1, a2, a3, by the explicit formula ak is equal to k divided by k plus 1 for all integers. K is greater or equal than 1. Mean when we put the value of k, that will be that will start from 1, 2, 3 and so on, all the greater value of k. The first 4 terms of sequences of this explicit formula is 1 by 2, second is 2 by 3, third is 3 by 4, and fourth is 4 by 5. When we put k is equal to 1, the in this formula the value of a1 is 1 by 2. When we put the value of k is equal to 2, the value of a2 is 2 by 3. When we put the k is equal to 3, the value of a3 is 3 by 4. And when we put the value of k is equal to 4, the value of a4 is equal to 4 by 5. These are 4 terms of a sequence. The first term is 1 by 2, second is 2 by 3, third is 3 by 4, and the fourth one is 4 by 5. There is an example. Write the first 4 term of the sequence defined by this formula. Here we put, and for all j is greater or equal than 0. It's mean the first value of j we will take 0 because j is equal to 0, and then we take the greater values of 0, 1, 2, mean we start 0, 1, 2, 3 and 4. And we want to find here first 4 terms. So first term we will put j is equal to 0, and second term we put j is equal to 1, and third term we put j is equal to 2, and fourth term we put j is equal to 3. Okay, the formula is bj is equal to 1 plus 2 power j. So first of all put j is equal to 0, the value of b naught is 2, and when we put j is equal to 1, the value of b1 is equal to 3, and when we put j is equal to 2, the value of b2 is equal to 5, and when we put b is equal to 3, the value of j is equal to b3 is equal to 9. These are the first 4 sequences, 4 terms of a sequence of this explicit formula. Now there is an exercise. Compute the first 6 terms of the sequence defined by the formula. This is the explicit formula. Cn is equal to 1 plus into minus 1 power n for all integers n is greater or equal than 0. It's mean we took the first value of n is equal to 0, then 1, then 2, then 3, and then 4, then 5. Until 5, when we take n is equal to 5, there will be total 6 terms of a sequence. The first term c naught, the value of c naught is equal to 2, c1 is equal to 0, c2 is equal to 2, c3 is equal to 0, c4 is equal to 2, and c5 is equal to 0. The sequence will be 2 0 2 0 2 0. These are the 6 terms of a sequence, and you will write in these terms in a comma form. Now there is an arithmetic sequence. A sequence, first of all, we will define arithmetic sequence. Arithmetic sequence is also called arithmetic progression. What is arithmetic sequence? A sequence in which every term after the first is obtained from the preceding term by adding a constant number is called an arithmetic sequence or arithmetic progression. The constant number being the difference of any two consecutive terms is called common difference of arithmetic progression, and commonly it is denoted by a small d. Okay, the common difference between two consecutive terms is called common difference. For example, there is a sequence 5, 9, 13 and 17. When we subtract 9 minus 5, there will be difference of 4. 13 minus 9, there will be a difference of 4, and 17 minus 13, there is a difference of 4. Mean the common difference in this sequence is 4, and the common difference of this sequence is minus 5, and the common difference of this sequence is 2a. When we take the difference of two consecutive terms, a sequence in which every term after the first is obtained from the preceding term by adding a constant number is called an arithmetic sequence, and the difference by any two consecutive terms is called common difference. And there are three examples of common differences. Now, general term of an arithmetic sequence is a n is equal to a plus n minus 1 d for all integer n is greater or equal than 1, where a1 is here there is mistakenly write a, there will be a1. An is equal to a1 plus n minus 1 d, where d is the common difference, n is total number of terms which we used in sequence, and a1 is the first term. Okay, now there is an example which we will solve by this formula. Find the 20th term of arithmetic sequence. It's mean the value of a1 is 3 here, and the common difference is 9 minus 3, there is 6. Common difference is 6, and the total we want to find 20th term, mean n is equal to 20 hoga, and we want to find a20. So when we will put these values in above formula, then a20 is equal to 3 plus 20 minus 1 into 6, and the answer is 117. It's mean 20th term of above sequence will be 117. Now there is another example. Which term of the arithmetic sequences 4, 1, minus 2 is 77 minus 77? It's mean here we want to find the value of an. Okay, the value of a1 is 4, and the common difference is minus 3. Okay, we put this information in above formula. An is equal to minus 77, and a1 is equal to 4. We want n number, which shows the number of terms, and we want to find minus 1 into common difference is minus 3, and when we solve, the value of n is 28. It's mean there are 28 term of given sequence is minus 77. There is another exercise. Find the 36th term of arithmetic sequence whose third and 7th and 8th term is whose third term is 7 and 8th term is 17. And this is the solution. By using this formula, we can easily find in first of all we will find the value of a8, 8th term we want to find. So there is, by solving this formula, the value is 73. The 36th term is 73, and the value of 8th term is given in above question. You can solve this question by yourself. Now there is another definition of series. The sum of term of sequence forms a series. If we want to define series, we already discussed sequences, and when we add the terms of sequences, then it will be called series. For example, we have a sequence a1 comma a2 comma a3 comma dot dot. When we write it in this form, a1 plus a2 plus a3 comma dot dot, it's mean this will be a series, like this way, like this form, a1 plus a2 plus a3, and we write it in summation form. We know that there are infinite number of terms, so k is equal to 1 2, starting term is 1, so k is equal to 1 to infinity ak. Summation, the capital Greek letter sigma is used to write the sum in a shorthand notation, where k is the variance from 1 to n represents the given in expanded form by a1 is equal to a1 plus a2 plus a3 plus dot dot plus an. More generally, if m and n are integers and m is less or equal than n, then the summation from k equal m to n of the ak is it will be summation k is equal to m to n, ak is equal to am plus 1 plus am plus 2 plus dot dot plus an. And this is the end of our sixth lecture, which is related to sequences and series. Inshallah, we will meet in our lecture number 7 next week. And best of luck. Goodbye. Take care. Allah Hafiz.